Okay, Wildcat, so we're going to have 4. Building cubic functions. The student works 1, 2, and 3. Let's take a look at the next page. Getting started. Don't be a cubic group. You previously built a cubic function by multiplying 3 linear functions and by multiplying a linear function and a quadratic function. Let's explore how the properties of linear and quadratic functions determine the key characters of cubic functions. 1. Sketch a set of functions whose product builds a cubic function with the given characteristics. Okay, so 1A. So we have zeros at 0 to -5. Okay, so our graph comes up, goes back down, and back up. Okay, go ahead and finish up 1A. Let's take a look at B. So we have a 0 at -3, and we have a 0 at 4 with multiplicity. Okay, so we come up, go back down. Because of multiplicity, we touch and turn. All right, go ahead and finish up B. All right, let's take a look at the next page. All right, go ahead and mark out this page. 4.1, building a cubic function. The key characteristics of the individual functions that build a cubic function reveal properties of the polynomial. 1. Analyze the linear and quadratic functions that are shown. Choose a set of functions from the function provided whose product builds a cubic function with the given characteristics. Okay, so 2 imaginary zeros and a real zero. So we have, let's go ahead and use g of x times g of x, which is equal to x plus 1 times x squared plus 1. And let's go ahead and find the 0. So we said x plus 1 equals 0, x squared plus 1 equals 0. So we subtract 1 from both sides, you get x equals -1. So you have 0 at -1. Now we subtract 1 from both sides, you get x squared equals -1. Take the square root of both sides. Remember, square root is plus or minus. Square root cancels the square. You get x equals plus or minus the square root of -1, which equals plus or minus 1i. So x equals 1i and x equals -1i, which are your 2 imaginary zeros. Okay, let's go ahead and graph this in Desmos. And we already have our 0, 1, -1, 0, and let's go ahead and use the y-intercept of 0, 1. Okay, so our graph looks like this. All right, go ahead and finish up 1A. All right, let's take a look at B. So it says a y-intercept of 0, -1, which we have. So let's go and use the function g of x times h of x times j of x, which equals x plus 1 times x minus 1 times -x plus 1. And let's go ahead and find the 0. So x plus 1 equal to 0, x minus 1 equal to 0, and -x plus 1 equal to 0. Okay, so we subtract 1 from both sides to get x equals -1. And now we add 1 to both sides to get x equals 1. And then here we subtract 1 from both sides to get -1x equals -1. Divide both sides by -1, so you get x equals 1. So x equals 1 multiplicity of 2. Okay, so that means we're going to touch and turn there. So we're going to come here, back up, touch, and turn. Okay, go ahead and finish up 1B. Let's take a look at the next page. All right, C. So we have x equals 1 multiplicity of 3. So that means we're going to have a 0 right here. So let's use the function h of x times r of x, which is x minus 1 times x minus 1 squared. So we set both of them equal to 0. So we add 1 to both sides. You get x equals 1. Here we take the square root of both sides. Remember, square root is plus or minus. Cancels the squared. You get x minus 1 equals plus or minus 0. So we add 1 to both sides. You get x equals 1 plus 0, which equals 1, and x equals 1 minus 0, which equals 1. All right, let's go ahead and graph that in Desmos. Okay, we're going to use a point 0, negative 1. So we come up and like so. All right, go and finish up 1C. Well, let's take a look at D. Okay, so 3 distinct zeros. So let's use f of x times g of x times h of x, which is x times x plus 1 times x minus 1. So we set each of them equal to 0. So we have x equals 0. Subtract 1 from both sides. You get x equals negative 1. And add 1 to both sides. Get x equals 1. So we have 0, negative 1, and 1. All right, let's go ahead and graph that in Desmos. So x times x plus 1 times x minus 1 All right, so looks like this. All right, go ahead and finish up D. Mark out E, and let's take a look at the next page. Yeah. 3 imaginary zeros. Explanation. Not possible. A cubic function increases or decreases from left to right, so it must at some point intersect the x-axis. All right. 2. What are the possible combinations of real imaginary zeros that a cubic function can have? Explain your reasoning in terms of the functions that can build a cubic function. A cubic function can have 3 distinct real zeros, a double real zero, and a third distinct real zero, or 2 imaginary zeros and a real zero. All right, mark out 3. All right, let's take a look at the next page. Go ahead and mark this page out. The teacher works 5A and 5B, and the student works 5C. 5. Write 2 different cubic functions with the given characteristics. Okay, so we're going to work backwards to get the equation. So if we have x equals 2, x equals 0, x equals negative 4. So we have x equals 2, x equals 0, and x equals negative 4. Okay, so we're going to go backwards, so we're going to subtract 2 from both sides. You get x minus 2 equal to 0. Still x equals 0, nothing to do there. And then we're going to add 4 to both sides. You get x plus 4 equal to 0. So our new function, let's call f of x, is going to be x minus 2 times x plus 4. But it's unconventional not to put the x in front, so we're going to rewrite this as x times x minus 2 times x plus 4. All right, let's take a look at B. So we have x equals 0, x equals 2i, and x equals negative 2i. So again, working backwards to find the equation. Well, x equals 0, there's nothing you can do. Here we're going to subtract 2i from both sides. So then that's x minus 2i equal to 0. Here we're going to add 2i to both sides. We get x plus 2i equals 0. So our new equation, let's just call f of x equals x times x minus 2i times x plus 2i. Alright, go ahead and finish that up and work C on your own. Alright, let's take a look at the next page. Talk to talk, a rootin' tootin' good time. 1. Complete each statement with always, sometimes, or never. Explain your reasoning. A. A function of the nth degree always has n zeros. B. The number of x-intercepts sometimes matches the number of zeros of a function. C. A function sometimes has imaginary zeros. D. A function never has an odd number of imaginary zeros. And E. An odd degree function always has at least one real zero. All right, let's take a look at the next page. All right. Student works 1A, 1B, 1C, 1D, 2A, 2B, 2C. All right. Let's take a look at the next page. The student works 1A, 2A, and 2B. All right. Go and finish your notes and start working on your assignment and have a wonderful Wildcat day.